Hello, my name is Ashlyn, and this is my assignment, or I prepared a short slideshow, basically, of the differences and characteristics of hydrophilic and hydrophobic substances. So, a hydrophilic substance, let's break down the word particles. Hydro actually means is a Greek word for water, and the suffix philic also means likening, tendency, or attraction. So if you put these two words together, it means water loving or tendency to attract to water. So in order for a hydrophilic substance to be a hydrophilic substance, it needs to be, of course, miscible, and it has to be, easily mixed with water. So say an example is if we have we pour a can of soda, what it does is it's fizzing out, it's displaying an example of, it's explaining the example of what a hydrophilic substance is. Or the polar bonds, it has to have hydrophobic bonds, ionic bonds, and covalent bonds. Also, a hydrophilic substance can be a liquid, gas, and a solid. Right here I have a cup of a fluid being dissolved, whatever fluid's in there. So examples of hydrophilic substances are alcohol possesses hydrogen hydro bonds. Methanol, it's actually a type of alcohol. So alcohol is very solvent. It can dissolve easily with water. Actually, I think it's about, I can't remember the percentage, but I think it's about 30% of water's in alcohol. I might be wrong though. And glass, depending on the temperature of right here we have a glass right here, depending on the temperature of the glass and if there's any fizziness, I'm going to use the soda example. You pour a fizzy water or fizzy soda into the glass, it displays the fizzy gas, bubbles that'll bubble to the bottom, but then eventually they disperse. Other examples we have are wood, but wood actually it softens if it reaches water, and depending on how soft it is and if it's really brittle, it might not dissolve at all. And we have starch, which if you pour cornstarch, depending on how much it is, it either will cage up or it can put little it won't dissolve properly. Alright, and oxalic acid, ammonia, and of course we talked about protein. Actually, if a protein denaturates, it'll lose its ability to dissolve and eventually die. That's for a protein cell though. Now, the term hydrophobic, which I'm pretty sure you can already tell, phobic, the suffix phobic also derives from phobia, which is afraid or fearful, and we already talked about hydro means Greek, the Greek term for water. So I put a little symbol, water means it's water fearing or water repellent. So some characteristics of being a hydrophobic substance: it has low energy surface materials, it can attract nuclear molecules and nonpolar solvents, and it can have a characteristic shape that's it'll form a little tiny water droplet. I'm pretty sure after you see rains, there'll be little rain droplets on those green leaves that you see in a plant, and you'll see the little water droplet on there. That's called the lotus effect. So after rain, if you ever get a chance, you can see the little water droplets on the leaves. So examples of hydrophobic substances. Of course, we know oil and water never mix, so I put some examples. And fats, it all depends on the type of fat, but think of putting chicken into a glass of water, which I know you probably won't, but that type fats don't really mix well with water. It can only absorb it to some. It might exert it, but doesn't mean it's gonna dissolve it. And of course we have methane, ethane, and propane. Steroids, think of taking a capsule and putting it into a glass of water and see if it dissolves. Probably doesn't. Greases, and of course wax. Now, let's talk about how do we know if the substance will absorb the water or repel it? Well, in order for it to be hydrophilic, it has to have polar molecules, a positive and negative charge, and solvent molecules. So the key term is solvency. If it cannot dissolve, if it doesn't have any polar properties or molecules, it won't dissolve. Now, if it's hydrophobic, it has to have non-polar compounds, non-solvent, which we said hydrophilic is solvent, hydrophobic, fearing, repels, non-solvent, and it has to cluster together in water. So another example is when you put a solid like oil, basically, or when you put like I guess pepper, it doesn't really dissolve in water. So next time you think of like putting like a powder-like substance, they're actually powders. Certain powders do not dissolve in water. Like makeup. Makeup does not dissolve in water. Or anyways, you get the point. So, now there are interactions with water. As we talked about earlier, substances diffuse in water. If it's hydrophilic, water moves and pulls it apart. I'm going to use that fizzy water again. The pouring fizzy water, and it disperses and pulls apart. The molecules pull apart. And if it's hydrophobic, it separates from the water. Use a heavy powder, for example, produces a cage, like those little like powder molecules you see to make space for the water to come in, and it reacts. There's no reaction after that. So you can also do a test and see how that works. Now here are my references right here. I want to thank you guys for watching this video, and hopefully my explanation is clear enough. Thank you.